about if you're doing this for 8 hours a day, it's a big difference. I mean, literally, theoretically, you could do it one day and take another day for 3 days.
Hey, can you do it? Hey, can you do it again without the music in the background? Because we can't put that on YouTube.
Right. We can do that. I mean, you know, Teddy's back with their hat on sideways. Albums, mixers, but we can shut that down. Yes, we can do that.
Yeah.
If you want, we can go back and do that later.
Yeah, a couple times.
Cool, we'll do that. Okay, so the next category is metal cutting, and you know, this is an area where it's actually 65% of the market. You generate a lot of high heat, and the problem is that you have a standard blade. You have the front tube cutting, and every tube is exactly behind it. So you got a lead tube, and think of it, the rest of the teeth are like a shadow, right? They're just kind of in the shadow of it. So to counter this, we did what's called a full contact. We put a slight arc where all the teeth are engaged in material, right? So every single tube actually cuts the metal. And the results are much faster, less vibration, longer life. So to prove this out, how are we going to do it?
We have 1-inch schedule 45 pipe, standard gas line. I'm using a Diablo bimetal or medium metal full contact arc.
And I'm using the Milwaukee bimetal.
Okay, so the best thing to do here is we're going to make 3 total cuts, and we're going to time each one, because we're going to attempt to show you 2 things. One is the speed of cut, but also the consistency of the time of each cut. So we'll do that, we'll time it out, we're legit. Power settings, speed 2, yeah, 5 pounds away, 5 pounds away. Okay, I'm going to count. 1, 2, 3, go. Count. 1, 2, 3, go. Okay, third and final. 1, 2, 3, go. Okay, so you can see the speed is incredible. Think about if you're cutting that all day long. This is a big deal. It significantly reduces vibration and cuts a lot faster, right? Cool stuff? All right, so the game changer we introduced 5 years ago is we recognize that bimetal, which is steel on steel, can only go so far in terms of cutting performance. And we were the first in the world to bring out carbide tip reciproc blades. In fact, it was nail embedded, was the first version that we brought out, like I said, about 5 or 6 years ago. And really, you think about it intuitively, that makes so much sense. And circular saw blades is all carbide, and router bits is carbide, hammer bits is all carbide. Every category where the carbide comes in, it really takes over and dominates. And this is a core competency. We're vertically integrated. We make our own carbide. So, and now everybody goes, well, everybody else is starting to come up with carbide too, right? How does your carbide compare to other carbide? We think it's awesome that more and more players are coming into this space because everybody's talking about carbide. And carbide at 2 times the price is delivering 50 times the performance. And that's good for everybody in this area. So our carbide's better than their carbide. Now we're going to show you a little bit. We're on version 6 and what the difference of our core competencies can do in everyday performance out there. So, guys, Logan, Mike, how are we going to show this?
2 by 12, and we have 10 fluted masonry nails. A very difficult application. I'll be using the Milwaukee Axe carbide.
Yep.
I'm using the Diablo nail embedded wood with carbide teeth.
Yeah, before I go, you guys just look at me and tell me if you're not ready, we'll stop and wait until you guys can get set up properly.
The 2 most famous guys ever, right?
Make sure you got your safety glasses now, guys.
Let's do it. And you ever feel like someone's watching you guys? I'm not. 1, 2, 3, go. real strong. And so we're feeling pretty good about ourselves, right? So let's take it up to a different level. So we're gonna take the same blade that's made that cut with the Diablo, and we'll put a brand new Lennox carbide tip, nail and bedded wood blade, like for like, same for same, except the Diablo already made a cut. The Lennox is a brand new one. So anything that happened to that? Let's see what happens. On my count, 1, 2, 3, go. Okay, so you get the point here. Carbon tip blades are not all made equal, but we're excited that more and more people are getting in. It just kind of justifies and solidifies that I think we're on the right path. All right, moving over to thick metal. This collectively, a lot of you guys in this room had a lot of fun with this thing. This was a blade that really changed the industry up until this point. Really could really cut mild steels. You could never think about cutting stainless steel, cast iron, boron, advanced lightweight steels. This blade really changed the game in terms of performance we got everywhere. So now, as we know that more and more players are entering the market, and I'm trying to overwhelming feedback from you guys is that how do you compare versus the rest of the market? I'm going to show you how. So, what do we got here?
I'll take it.
Okay, Mike.
Piece 2-inch stainless steel, 304, schedule 40. We're using the Diablo carbide tip for thick metal.
Yeah.
I will be using the Milwaukee carbide for metal forge.
Yeah. Okay, you guys want to come on up? Do whatever you do. Everybody ready?
We will be feathering the curve, set a pilot.
Yeah, so that means, you're going to get a pilot going and up until the wood. So, on my count, 1, 2, 3, go. So you see, the first cut actually pretty sizable. You guys remember the CSA? They're an independent testing group. We just got the numbers back, and we have 5 times performance versus carbon tip torch. So pretty cool stuff. And then the last thing I just want to show you in these blades is that, the fact, who here uses a portaband tool? So what do you use that for? And why do you use that over a recent song? Vibration, noise, what else?
Cleaner cut.
Cleaner cut. Cleaner cut, what else? Straighter? It's a cool tool, right? Cool tool. But this actually isn't necessarily a great tool to be able to hold it up. Now, if you're in your shop and you're working at it, no doubt. But if you're in the field and you're trying to cut a piping and you're on your back, you're on your footings, you're in the rope, not so cool, right? So when you're limited with the opening, it's under 5 inches. It's 4 5/8, I believe, to be exact. So you are going to be limited. So the number one application typically is strut. And so now we've developed a medium metal carbide tip solution that's actually giving you like a portaband performance. And everybody we talk to, if given a choice, they'd much rather use that tool if you can get the cut close. So how are we going to illustrate this?
We have a piece of 304 stainless steel strut. I'll be using the Diablo medium metal with carbide teeth.
I'm using the Portaband 18 TPI Milwaukee band.
Okay, on my count. 1, 2, 3, go. look at the cut itself, it's pretty straight, and the finish is pretty good. And so on the job site, if you can use recipe salt all day long, customers are going to prefer to use that. So now it gets a little interesting in terms of this tool substitution, right? Good stuff? All right, so let's transition over here. And you're going to see a lot more innovation come on recip blades. Next year, we have a lot to talk about. But we're actually working on a recip blade that actually we call a portaband blade. So one quick thing you may or may not realize in saw blades, and we haven't talked about this at any of our media events, but we dominate in industrial blades. We go up to 800 millimeters. And these are designed for the SCM machines where you have a $250,000 panel sizing machine, right? You're putting 10 to 13 sheets of melamine on it, and you're banging these things out for 8 hours a day, 3 shifts a day, 7 days a week. You can't give a free cooler or a soccer ball or a NASCAR promotion around these blades. Either they chip or they work, right? And so that's what we dominate. Well, we learned a lot of our designs on this and actually translated them to Diablo. In fact, Diablo is made in the very same equipment that our industrial blades are made. And oh, by the way, we dominate in China. We have the overwhelming #1% market share, and a lot of the Chinese goods that are manufactured are bought by German or Italian machines with our blades. So that's kind of cool. And just because they see the value, the cost per cut. One small thing too, if you look at this anti-vibration, you know that vibration is the death of anything. Once it starts dancing like that, it wears prematurely, and it affects your quality cut. So what we've done, wow, whew, where'd you come from? Like Mr. Deeds? You got a little cut. So a standard blade, actually, if I put it up to you, whoop, I think everybody knows the standard blade, they ring like a church bell. But when you put this anti-vibration design in here, you see that already this is still ringing, still vibrating, still making noise. And when you're cutting at 5,500 RPMs or 1,800 RPMs, it's going to dance all over the place for you. And that is bad for, like a tire, if it's not properly balanced, it's going to wear prematurely and give you a rough ride. Saw blades are no different. And you can see that the same anti-vibration design here came from our industrial blades. So, yeah. Dinner time. That's right. Good stuff? All right. So the technology that we're starting to use on our blades are getting sick, and the separation is getting greater. And more of our colleagues are coming out with premium designs, yet the distance is getting farther. And that's because we're vertically integrated. If you don't make your own carbide, you're not in the game. It's about 80% of your value to these type of products. And it means everything. So we're vertically integrated. We'd love to get you guys sometime to Italy. We're an hour and a half north of Venice. It's a beautiful part of the world, and we have the most sophisticated manufacturing. Even by automobile standards, it's considered highly robotic. I mean, you'll walk in, you'll think everybody's at lunch. All 100%. Within a 3-hour radius, you have Lamborghini, Maserati, Ducati, just badass Italian engineering. And it's really cool to be able to put this into our cutting tool product. So we're going to show you how badass this Italian manufacturing is. By comparing it to 7.25, you got a 5007 NB Makita #1 selling circ saw on the East Coast, or you put the Mag 77 Skill for the West Coast. And when you're cutting now, you can really improve the technology of these saws dramatically just by putting a blade. So we're going to attempt to show you what some of these new technologies do in terms of performance versus some of the newer players that are coming on the field claiming premium, right? So Steve, how are we going to do this?
Okay, thanks Russell. So again, as he indicated, we're going to start off with the Makita, just the standard 5007. This is the magnesium version 15 amp sidewinder circular saw. And we're going to cut this 2x12. It's topped with 2 layers of asphalt shingles, 2 layers of aluminum flashing, piece of 1/4 inch plywood, but in addition you can see there's 1/4 inch lag bolts embedded the length of the board. So that's a total of 80 lag bolts from start to finish. And so I'm going to start off with the Milwaukee. I'll even turn the right side up. The Milwaukee, the new 7.25 24 tooth carbide tip saw blade. This is something that was recently launched, and it's a great example of what Russell touched on was, you can take a great design. I mean, Milwaukee's a great company. They've got a good design here, but when you take inferior components, inferior carbide, inferior processes, it's difficult to control that outcome. So we're going to attempt to show that, like Russell said, in this nasty rib sandwich. I just want to caution everybody there. What you're going to see is that carbide is going to wear very quickly as it encounters these bolts, and you're going to see a lot of sparks. So please, anybody up close, let's get some glasses on. Yeah, sorry, Paul.
Oh, I can't be here?
I don't want to throw it out the back, because if any kind of metal debris comes out. Okay, and we got to be careful down there too when I get to the Diablo. So, all right, here we go. So that became so difficult to cut as the carbide dulled out. It became so difficult to cut. I was losing contact with the surface, and at that point, it's really unsafe, and I didn't want to continue.
Steve, crack it open.
Yep. So just to kind of give you an idea of what's going on in there. You can kind of see as it's burning its way through. It started out nice, but as it dulled out, it started to burn. Up here to the end of the cut, it really just started to burn. Heat breaks down carbide. So superior carbide, superior design will allow you to continue to cut. All right, so one thing we wanted to show in addition to the Diablo today, we actually want to show our opening price point blade. So this is our 7¼ inch 24 tooth Avanti blade. So when I say opening price point, it's a $5 carbide tip saw blade. Traditionally that $10 range has been that premium level. But the Avanti at $5, again, we make this carbide. You know, it's a different quality, different specification of carbide than our Diablo. But because we can control that process, I'll give you a taste of what that looks like when it comes to performance in a nasty rip. So, ready? Usually when you burn the blade, the lights go off, but extra energy. But again, at a $5 price point, you can see if you control the carbide and the other processes that go into that saw blade, it delivers a great performance for that price. All right. Thanks, sir. So now we're going to move on to the Diablo tracking point. Diablo tracking point to 20, again, our $10 24 tooth framing blade. That we launched several years ago, but we've continued to take advantage of our Freud heritage and the carbide and the panel saw blades, and have a positive impact on the performance of the tracking point blade through tolerances, through tweaking that carbide blend, through different designs in the plate and the teeth and grinding. We continue to raise that level of performance and bring solutions for the job site. So just to kind of give you a feel for what that looks like, let's give the Diablo a go. We can clean some of these materials out of the way, and it should be fine right there. All right. Yes, sir. And you should be able to hear right away the difference, and also see the difference in the speed.
Yep.
All right. You got that, Eric? All right. Sorry, I didn't mean the audio there. Okay, here we go. So that is the performance of carbide, of all that technology, tolerances, Diablo tracking point. Way to go.
That's strong. That's strong. Now, we may get a little DUI if we look at this down here at the end. No, that's awesome. Good stuff?
Good stuff.
All right, so now we're going to show you a first in the world scenario. And let me start off with just asking a simple question. These two saws tend to dominate the market. What are they used for primarily? Frame, right? Wood. So what we're excited about, and we're not aware of anybody else doing it, this is the first in the world wood and metal cutting blade, which will double the applications of these standard circular saws. Now, we filed the Power Tools recommendations. We're not going to go outside of that. So from 7 1/4 and under wood cutting saws, now with our metal cutting blades, you can put them on, right? So we're going to hit a retail at $22 that you can go out there and cut metals and wood with a circular saw. Now think about when you're using a grinder, and I hope you guys stop using grinders because they're not safe. And you think about 15,000 RPMs by your body, nothing good is going to happen. And by design, and by design, you're spinning at a zero hooking. You can't have a positive hooking in grind. And so material is wearing on it makes it a very unsafe experience. Cutting steel is the safest way to do it. And you're going to see it's cool. It's the finish is strong. The finish is good, and you're ready to go. So right on. So now this is not going to replace a wood cutting blade when you're framing all day long. This is not going to replace a metal cutting blade when you're cutting metal all day long. This is a general purpose blade. You're like, hey, I got to cut a lot of little stuff. So you throw this thing on. You guys do a lot of metal working. You do a lot of wood working. You throw this blade on and do everything with it, right? So we're going to attempt to prove this out. Steve, what do we got?
Okay, so again, it's metal and wood blades. So we're going to start off and cut a variety of metals and then transition back into wood and fasteners. And then cutting also try to give you a feel for the different trades that this is going to touch. So I'm going to start off with just standing on a 4 rebar. About a 1/2 inch rebar. Commonly found on any job site that's pouring concrete. Those same end users are cutting form boards that are coated with concrete or embedded with fasteners. But also, they're using a grinder or a gas saw or a chop saw to cut off the rebar. So then I'm going to transition into 3/4 inch threaded rod. Get those mechanical trays that are hanging in this truck, different applications for all thread. And then we're going to go back to the 1 inch stick 40 black pipe. And then I'll transition back into the 2x12 loaded with some fasteners. So,
Okay. So the good thing is we want everybody to go home safe for the events, the Diablo events. So this little guard right here, we're going to put in front of you guys because we'll start off with an angle grinder. And we're going to, by the way, we're going to put a brand new wheel on it, which we have. And you're going to see how fast this actually wears down.
I'll be right here.
You'll be right here. The shield will go right in front. This way no one has to worry. Everybody goes home safe.
All right, so again, we're going to start out with the rebar. For this kind of give you an idea of what it looks like today with angle grinder. So I'll try to do that if I can. This one should really angle. Okay, as you can see, a lot of sparks, a lot of dust, and a real high RPM like Russell was talking about. So this is the metal wood blade, the 36 tooth Diablo metal wood, brand new. It is turned around backwards because I'm using the Makita 36 volt rear handle saw. which is the left-hand blade, but I think we notice quite a dramatic difference here. Just nice and easy. Very controlled, it's cool to touch. I can just keep going on and on and on. If I need to transition to a different material, I can. So let's go to a different type of metal. Load up the 3/4 inch all thread. Thanks, sir. And once again, I'll give you an idea of what does that look like today with the grinder. There's several different ways to cut it, but we're going to continue to focus on that bonding category. And let me get my gear on here just in case. Okay, so I kind of burned my way through that, and now let's say I wanted to, it's really hot, and then because of that big burr right there, it'll make it really difficult for me to try to get that threaded on there. So I'm not even going to. So the solution is the new 36 tube Diablo blade from metal and wood. So let's see what that looks like with the new Diablo saw blade. Yeah, nice, easy, cool to touch. I can grab hold of that. And just get my nut. Thread that on.
Get your nut on.
Back to work. All right.
Too soon. Too soon.
All right, so black pipe, maybe not as hard as the other two materials, but the challenge here is it's 1 inch in diameter. And these grinders, especially these bonder wheels, as I use it, I'm only made 2 cuts. You can see I've already lost some of the diameter. Now I want to be safe and keep my guard on. I know a lot of times in the field you see, first thing that happens is that guard comes off. Not a good situation. So just because of the loss of diameter, I have a difficult time, and I'll give it a go. See if I can make this cut. And there it is. I was hitting the front of that guard, or the front of the nose of that guard, and I just can't get by that. So we're going to transition to the solution, redefining metal and wood cutting. All right, and when we're done with metal, we need to switch over. Again, we're transitioning back into the wood category. But not only wood, this is a 36 tooth blade, so it's going to provide a nice, it's not going to replace the finished blade, but it has versatility. So what I have here is a 2x12 loaded with 4 16-pin nails and 4 construction screws. And we're just going to give it a go after cutting all that metal. We're going to give this a go through the wood. And that's the 7 1/4 inch version. It's also available in the 6 1/2. So $21.97 for the 7 1/4, $24.97 for that 6 1/2 inch version. So. Fantastic. Yeah.
So, I think the power tool companies are probably more excited about this blade than we are. Because it's really, it's sell a lot more new tools for that. So that's strong. Is that strong? Strong. All right, so the next area is probably our most ambitious area that we took out as an organization. And it's really, we are passionate about ridding the bondage. You can tell the bonded area, we don't like this technology. Do we have it? Yes. Begrudgingly, we sell it, and we really the use it. There's better solutions in the market. The problem is the value proposition has to make sense. So right now, a bonded wheel, if you put a bonded wheel on a circular saw, it costs $4, and a grinding wheel is $2.50, $3. And so you get 10 out of 10 people that watch a metal cutting saw blade make a cut and go, yeah, right, I get it, that's better. But then you say it's $55, $60, and they're like, I'm not going to pay that versus $3 or $4. So we have to make the math work better to go from a niche market to a mass market, right? And so right now, a standard metal cutting circular saw blade with carbide is rated to last 40 times longer than a bonded wheel. So for $2.50 or $4, people look at the math and they go, it doesn't make sense for me. I'm going to stick with bonded until now. So what we're introducing now is a cermet material. It's a ceramic metallic. It's not carbide. It's made out of ceramic and metallic that we make. We're vertically integrated. And ceramic and metallic material significantly can withstand a lot more heat than carbide, up to 30 to 40 times more. And so what our value proposition we're going to offer now is 640 times longer than bonded, not 40, 640. Now you guys are saying, no way, no way. We're going to prove it to you. The second thing we did is we took a $55, $60 category and we took it down to $30, right? So we increased performance radically and then took the price down. So now this value proposition, it works, it works. So we love you guys, hopefully are skeptical. We're gonna attempt to show you this. And this is kind of cool though, right? So how are we gonna show this? And before we start, we're gonna go up against metal cutting circular saw blades, and you guys get to choose. We have a Lennox that retails for $60. We have an MK Morris that retails for $55. So any, you guys want to choose? Lennox.
Yep,
MK
Lennox.
Lennox. There we go. Lennox. Nice. All right. How about the show of hands for Lennox? Show of hands for MK Morris. It should come back. Yeah, we can come back and show. And what you're going to see is there's
Burn. Hey, new subscribers have more pull. That's all I'm saying.
Okay, and sorry guys, again, cutting this stainless steel, I can throw little pieces and we want everybody safe. So I'm sorry, we're going to ask you to move back a little bit. Gentlemen, we can move this the shield. For your own safety.
So Russell, we've got, this is an 8.5, 3 or 4 gauge stainless steel. The common application is handrails, food service, fabrication for building tables. And stainless steel is a very, very high heat situation. So a standard carbide tip blade, which you're going to see here from Linux, you'll see it as that heat builds up, carbide breaks down, and it just can't complete the cut. So you're going to see a lot of sparks and very, very early in the cut, and then it just cannot complete the cut, and now you're stuck with a piece of a big burr hanging off the edge, and then we'll stop there and transition to the Diablo cermet. So, Liv, you ready? And we highly recommend hearing protection on this one.
What?
Nice morning.
What?
Huh?
Dark horse.
Oh, I have some. These things doing a lot of good back there.
Protecting the behind ears. Oh, your hearing protection.
Yeah, there you go.
How's that work?
That's a good spot
So this
to
is
hold
the
them.
Diablo 7/4 48-2 steel demon. Again, we had this.
That's where I always put them on the job.
In the market for years, with standard carbide teeth, and now, again, first to market at this higher RPM, this is the 5,800 RPM sideline install, and let's see the difference that cermet brings to this application.
That's crazy.
I'm gonna reposition it, and you can see we're counting. I have my counter going back here, so that's 20. So here we go with the second round. All right, there.
This is a loop video.
All right, I follow up, so we got a decision to make.
No, we believe you. We don't want to keep going.
Okay, so this will go over 100 cuts. We convince you guys that we can keep going.
You cut the bench off.
Yeah, well, we can do that. Trust me, we've done that. Not on purpose. No, 100. It'll go over 100 cuts. Significantly over 100 cuts. And we'll keep going if you guys want to, but we want to make the point, it's that dramatic of performance. So we're taking a $60 market down to $30, right? And we're increasing the performance by over 40 times existing blades on the market, which is just, that's the breakthrough. Hopefully you guys are super pumped on this thing.
So no one else uses that same technology?
No one's using CERMET in small diameter at this price point. So we have not seen another CERMET blade on the market, certainly not at this price point, certainly at this performance. Yeah, for sure.
That's crazy, guys.
That's awesome.
Yeah, you know, and hopefully you guys are fired up. And why would you ever use a bonded wheel now? And we're going to show you here just really, I mean, just find how dangerous it is. And I follow a lot of you guys out here in your projects and what you're working on. And these are applications you can do every single day. You can do it safer and better, which we're really excited about. Okay, want to bring it home? So pretty cool, badass Italian manufacturer, right? We're psyched on this thing too. And again, we're vertically integrated, which took us a while to figure out how to do the CERMET, but now we got it down with. All right, so we'll bring it home at the end. This is pretty cool. It's the stationary portion of it. Now, why do you use a stationary saw versus portable?
Accuracy?
Accuracy? Absolutely. What else?
Clamping.
Power,
Safety.
safety, depth of cut, so you get thicker materials, right? And when do you use this typically over, what applications?
In the shop.
In the shop.
Bigger materials, maybe?
Typically, it's in the shop, fabricating versus, but a lot of people will try this out the job sites, no doubt. But usually you're doing the same cut over and over, repetition, right? Versus portable, you're in a lot of just different either installs, you're fixing the model and whatever. All right, so we're going to show the difference of a bonded, and so a bonded wheel is about $9, depending where you're shopping, right? And then we're going to go after diamond technology, which retails for about $130. And the benefit of diamond is it doesn't lose the dimension like bonded, right? But that's going to give you a little bit of cutting experience. And check out these heats that it actually cuts at. It's going to blow your mind. And you guys are probably using this stuff right now. I have no idea what kind of heat you're generating, which is very, very dangerous. And then we're going to transition to our new CERMET large diameter blade that that we're aware of is the only blade will cut mild steels and stainless steels. Now, we're not designing a bunch of products for stainless steels. Stainless steel is about 17% of the market, we're only at 40% a clip, but we're just showing you the accelerated. You know, mild steels, we'd be here until 8 o'clock tomorrow morning. So we are showing accelerated, but we're gonna show stainless steel, and we'll show diamond products and the heat that it generates, and we'll show that this one blade cuts both mild steels and stainless steels, and see the difference when you're cutting versus grinding, which is a superior way to do it. So, Blair, tee it up. What do we got?
So we're going to start off with bonded or diamond. Working at Cermet blades, we're going to start with a 304 stainless steel with a pretty heavy wall thickness on there. Start out with the bonded, see how it goes.
Oh, and we got a, sorry,
Screen's coming over.
got the screen. And we could use some help. Who wants to pick that up? What? How much? 290. Celsius? All right, it's 290. Now,
Still a little hot.
what is it?
160 pounds.
169. Okay, so yeah, probably you put it in the water and woo, yeah, you can, right? I want another, branded, you can get branded with that. And so, hey Walker, can you do me a favor? Can you just go ahead and mic up the, before we start cutting? Did you already do that? Temperature? Yeah, the temperature. So just so you know what normal temperature is. So 75 degrees, right? So we were at 295 degrees, right, directly after that cut. Dangerous if you touch it. Now, if you look at the rework that you need for that, stainless steel, when it's discolored, it's very difficult to work with. You can't really undo that, as well as all the metal particles. You have to go back and clean that up. So now we're going to show diamond, and the benefits of diamond is that you don't lose the dimension. It doesn't wear like bottom, but it creates a lot of heat as well. It will be faster, but it generates a lot of heat. So, when you're ready.
All right, we'll get diamond. Super hot, poor quality of plastic, and then a lot of discoloration that's not going to be useful in this condition.
And by the way, this is the overwhelming way if you're cutting steel. All right, so 75 degrees, I think, was the benchmark in terms of room temperature. So now we're going to show you the difference in cutting Cermet And again, we're cutting versus grinding, which is significant. And again, is the safest way to cut. So, Blair, are you ready? Cool to the touch, right? And look how clean that is. It's ready, no rework required. You're ready to go with this thing. So significant difference, huh? Pretty radical.
So what RPM is that running at?
Well, that's 1,800 RPMs. 1,300 RPMs. 1,300 RPMs. And really with this too, I mean, you can really, he had it bear down with when you're grinding. He can go a lot slower with this, let the tool work. It's going to be, the quality's going to get even better and better with it. So this is a 72 tooth, but we also have a 90 tooth, so you can improve the finish if you like. Which we're going to show you now. So this is, again, 1472 retail, $89. Now we're going to show you a 14-inch 90 tooth for finer finish. And we're going to show you just what a great job we do on materials such as strut, where you do multiple applications on it in fine finish. And you're going to find, I think, when you're cutting at these price points, this is the way to go. Okay? 75 degrees. Okay. So 75 degrees. So it started at 75, after the cut ended at 75. Versus these temperatures. This is more, not math major. This is hotter than 75 degrees. Okay. So let's get into the strut. And then stainless steel strut. We're cutting. Again, virtually zero sparks, very safe environment, cool to the touch, very good, no debris, no rework needed, a pretty compelling transition. And this is what we're saying at the end of the day. If you look at this board here, you look at where the market used to be in terms of technology with grinders and bonded wheels and chain snaps. Right now, in the last 2 years, Charlotte Pipe, which makes 90% of the cast iron for the whole U.S., only recommend that chain snap. You see at the bottom of that. That's the way you actually put a chain around it, like a vice, and you snap it. Now all they recommend is our carbide tip recip plates to do that. Grinders are going to become obsolete if we market this correctly. And portabands, I think portabands has a place for it, but a lot of the applications will certainly be replaced. So kind of, that was then, this is now, is the message right now. Right on? So redefine the market, we can redefine the market together and make the world a little bit safer and better and really be more responsible, because if you're cutting with this indoors, you're breathing that all day long, as well as the sparks that are generated and people get hurt. And when we're in the field, very rarely do we see a guard on a grinder. That's the first thing that comes off, is they remove that because their dimensional wheel drops down. So with that, we'll end it with redefine the market together, and let's roll video one more time. And then we'll open up for questions, comments, Phil, everything.
Every day he's dealing with a new calamity. Lost his all
Yeah.
And what a treat it is to be able to do this in front of you guys. You guys are a little intimidating for knuckleheads like us, right? Because you guys are the best at doing this. All right, questions?
Can we see the demo again?
Which one?
The cutting the. Sorry. Yeah.
The sermon?
The sermon,
So
yeah.
Lars Damer?
Yes.
In comparison to, just do that one?
Can you do it again?
Yeah, absolutely. All right.
So what led y'all to the sermon? Since nobody knows more, what has led y'all to looking at that?
Yeah, so great question. So we, the question was, what led us to look at sermon? Sermon, what you're looking for is materials that can accept higher and higher heats. Like for example, does anybody have like a green egg or a green egg? It's ceramic, right? And ceramic can withstand significant higher